All right, so on the number line, you got to go from negative 13 all the way up to 1. So I'm just going to go negative 14. All right, so above the 1 is going to be what? Open circle going which direction? To the right. Above the negative 13, open circle going to the left. Now, let's write that in interval notation. So this was the new thing that we did yesterday. So remember, with interval notation, you're going to read your number line left to right. So what's the lowest number that's an answer here? The most left number. Nope. This arrow keeps going out forever to the left. Negative infinity. What that is. And then it stops at negative 13. Skips some numbers, and then where's it pick back up? 1. And where's that arrow go? To the positive infinity side. So there would be the graph, the inequality version, the graph version, and then the interval notation version of that. Again, parentheses for open circles, square brackets for filled in circles. And we'll get some of those as we go along here. All right. Number 2. Absolute value of 2x minus 3 is less than 19. Is the absolute value isolated? Yes. What symbol is between it and the number? Less than, so we know that this is an and problem. Okay. Remember yesterday when we were doing and problems, there were 2 different ways they were written. One of them was with the word and in it. And what was the other way? With a sandwich where you had the 2 numbers on each end. That's the way I'm going to set this one up. I'm going to set it up with 2x minus 3 is less than 19. And then I'm going to go over here to the other end, to the left side. I'm going to put another less than symbol and a negative 19. That creates a sandwich for an and problem. Okay? You always go to the left side, put another less than symbol. If it's a less than or equal to, put another less than or equal to, whatever the same symbol is, and change the sign. Now, how do we solve that problem? Plus 3 on both sides. So that's going to be negative 16 is less than 2x is less than 22. Divide everybody by 2. From negative 8 is less than x is less than 11. All right, so on our number line, we need some more room there. Extend it out here. What goes above the negative 8? An open circle. And then what goes above the 11? Open circle. Where are the answers for an and problem? In the middle. There's our solutions right there. What's the interval notation for that? Bracket or parenthesis on the other end? Parenthesis, because it's an open circle. So So we got the inequality, the graph, and then the interval notation over there. Easy stuff. Okay. All right. Let's get a little bit more intense here. Absolute value of x minus 1 over 4 is greater than or equal to 2. Multiply by 4 to get the absolute value by itself. Got to do that first. So we get absolute value of x minus 1 is greater than or equal to 8. And then we decide, is that an and or an or problem? It's an or problem because it's a greater than symbol. So we're going to set up x minus 1 greater than or equal to 8, or x minus 1, what's the other one? Negative 8, yeah. Flip the symbol, change the sign. And then we just solve each of those separately. Plus 1, x is greater than or equal to 9, or x is less than or equal to negative 7. On a number line, I don't know why I didn't think about doing this earlier. I'm going to go by odd numbers just because it works out real nice there. Don't have to put as many numbers on there. And that's legal. As long as you stay consistent. 11. Stay consistent with your scale. You know, go by the same increment each time. That makes it nice. And then above the negative 7, we have filled in circle, and it's going less than, so that's to the left. And above the 9, filled in circle, it's to the right. Remember, or problems, they go the opposite directions, right? So now let's get the interval notation for that. Well, you're going to do that. Negative infinity is going to go first because this arrow is going this direction, so that we're going to get to negative infinity and then negative 7 with the bracket because it's got a closed circle. That's right. Union, and then what? There you go. Good job. Easy enough, right? Measure about that. 2 more. Negative 1 minus 4, absolute value of x plus 9 is greater than or equal to negative 21. Add 1 to what? Okay. Why can't I add the negative 1 and the minus 4? That's still together with their. Okay, so what's going on between the negative 4 and the absolute value? They're multiplying, so you got to move the negative 1 first because you can't do the addition before you do any multiplying. So that gets that. So there's negative 4, absolute value of x plus 9 greater than or equal to negative 20 by negative 4 on each side. So when you divide by negative 4, it flips the symbol. So instead of being an or problem, it's an and problem now because it's less than. And because it's an and problem, x plus 9 in the middle, and then less than or equal to goes on each end. Change the sign. So I copy the original problem first and just take the absolute value marks off. And then I go to the left side, put another less than or equal to symbol, and change the sign. And then I solve that. Track 9, negative 14 less than or equal to x less than or equal to negative 4. So get negative answers in there, but that's okay. We're just getting our x values. Let's get it on a number line. So I know I'm just going to go by 2s. I don't need all of those, but I'm putting them on there. So what goes above the 14? Filled in circle, above the -4. Where are the answers? Between those, in the middle. Good job drawing that line. And then the interval notation. -14. And then a closing bracket. Yeah, bracket on both ends there. They're both equal 2s. Easy enough. Not bad at all. Good job. All right. Last example of the day. So we had -4, absolute value of 9 minus 3x minus 9 is less than 75. Okay. So you got to isolate the absolute value. So this stuff is not attached to it by multiplication. So I'm going to get rid of that 9 by addition. Get that part done first. So 75 plus 9, 84. And now what? Divided by -4. That's going to give us 4 minus, or I wrote 4 for some reason. 9 minus 3x greater than -21. Can an absolute value be greater than -21? Should an absolute value be greater than -21? Does it matter what's in the absolute value? No. So no matter what x is, if I put it in an absolute value here and work it out, no matter what the number is, when I take the absolute value of it, what kind of number is it? Positive. Are all positive numbers bigger than -21? Yes. So that means that this is a special case. This one would be all real numbers. Because no matter what x is, the absolute value is always positive, right? We know that about absolute value. And if it's a positive absolute value on the left side and it's greater than a negative, then we know for sure every number is going to work for that. So this is an all real numbers situation. The interval notation for that is -infinity to +infinity. Out of there. If it turned out to be this, can an absolute value ever be less than a negative? No, because they're always positive. So that's going to mean that if that were the situation, it would be no solution. If that were the situation, because your absolute value is always going to be a positive number, so there's no way that it's less than a negative number. Can't happen that way. Those don't happen very often at all, but they could happen. So we want to address those with that. Most of all of them you're going to see for the most part are going to have solutions to this. But keep in mind that's a possibility that can sometimes happen too.